It is an audience response system, and you'll see what it does as soon as this thing responds, which it should. There it does. Okay. All right. So turn it on and vote like A or something. You should see votes appear here. There you are. So the way this thing works, I ask a multiple choice question. You have like 30 seconds to answer. You can change your vote, and the last vote counts. So we've got 26 people that have got it working. I guess that'll do for starters. So this, I'm just showing you how it works. Now let's try some of these questions. Let me make my display as large as I can and get this out of the way. All right. There. All right. So what TCP/IP layer is HTTP in? One's enough. Just pick one. And I'll stop at 30 seconds down here. It looks like most of the votes. Oh, we're already 30 seconds. I'll wait till 40 seconds on this one. Ah, here we go. 35. What's that? You can't. You can change it, but you can't tell what your vote is. All right. So, all right, that is in the application layer, and that's a popular answer. Okay, not unanimous, but popular. But that's HTTP is in the application layer. These are worth points. If you get the most right, you'll get 3 points, and it can add up to a lot by the end of the class.
Wait. We actually getting ready for this right now?
You can get extra credit by doing it.
Oh, really?
Yeah. All right. And by the way, I'm supposed to take attendance, so I'm going to pass around a sheet, put your name on here, just so I know who's here. The only point of that is people who don't come to class and they don't turn in any homework and they don't appear to be doing anything, I have to remove them around the 4th week so that the state of California isn't paying us for students that aren't really in class. Anyway, all right. So where's IP?
Are you going to tell us the answer?
What's that?
After we do this, you'll tell us the answer?
Yeah.
Each slide or?
Yeah.
At the end?
All right, I'll quit at 30 here. It looks like the answers are in. All right, and that is at the internet layer. Again, the most popular answer is correct. All right. How many ports are there?
You mean how many most popular ports?
Nope. How many total? I'm quitting at 30. All right, there's 16 bits, so it's 65,000 possible ports. All right. What's that? I can't hear you. The answer is C. Okay, I could not understand your question, but I could guess from context.
So basically, green is always the correct one.
Yeah, that's right. That's how I grade them. All right, where's SMTP? All right, looks like I can quit at 25. I think the answers are pretty much in. All right, SMTP is on port 25 to send email. All right. And how about HTTP?
Are you sure this thing working?
If the light comes on, it should be.
I need my points.
If the light comes on, it should be working.
I need my points.
I'll quit at 25.
I used to be a soldier in the Army, police. I don't make no assumptions.
All right. But anyways, port 80. Port 80 for HTTP, and there's one more of these. Okay, you open a web page to go to City College. What is the first TCP packet that's sent? change it until 25. All right, the first thing you send is SYN, then SYNAC, then ACK. So SYN starts the TCP handshake. Good, I see a lot of right answers there. There, oh my God, good. All right, so we'll get back to more of those questions later, but we'll talk about them. So after TCP is the most popular protocol, because usually you want to make sure the data gets there, but sometimes you don't care. What you need is speed, and you use UDP. For example, you might have a security camera monitoring traffic in like a garage or something, and you just want it to continuously send that data. You don't want it to correct errors or resend lost packets. You just want it to keep going so you can look at it in live time. And then you'd use something like UDP. UDP is much faster and much simpler than TCP. There is no handshake. You do not know or care whether people are receiving it. It's like broadcast radio. You're just playing this stuff. People can tune in or not, and it doesn't have any effect. You're just spewing it out. So the internet layer is what finds the physical location of computers on the world. This uses a logical address called an IP address, and the IP is routed by all the routers around the world to find the physical location of the computer you're talking to. ICMP is used to send control messages. A ping is a simple message just to see, is the server listening? There are other ones. For example, if a router gets a packet and it is unable to forward it to the destination, it will throw it away and send an ICMP back saying packet undeliverable, so the source will know that that packet was thrown away and why, and they may choose to do something about it. There's typically the most common ICMP packets are H to request an echo and 0 to give you an echo, so you can see that a server is there. But there are other ones out here telling you that various things have gone wrong with packet delivery. And so that's what a ping looks like in Wireshark. It's very simple. It's just sending a request and getting a reply. One thing that's kind of fun about pings is an old ether leak vulnerability. Let me show you that one. So that's right, Wireshark. Let's see. Here, Wireshark. There we go. All right, let's just start capturing. And I see all this junk, but I can filter for ICMP. And then it'll be quiet again. And now if I ping google.com, you get a couple of pings coming back. Okay, here's the pings. I send a request and I get a reply, which is understandable. But if you take a look at these packets, it's actually kind of good, clean fun. Notice at the end of this packet, 0, 1, 2, 3, 4, 5, 6, 7, this is just garbage. And that's because there is a minimum packet size on an Ethernet network. You can't have less than a certain size, and a ping is too small, so it fills it up with junk. Now, back in the days of Windows 95, they didn't think about this. And when you send the reply, see, here's the reply with just these characters in order. They didn't fill that data with these random characters. They would just send you whatever happened to be in the RAM on the server. So you would get maybe 10 or 15 bytes of random data from the server that might have a password or a fragment of an image or an email or something in it, and they called that ether leak. Data would leak in and out. This came back with Heartbleed in 2014, I think, where it turned out that the new HTTPS protocol would leak up to 64 kilobytes of random data from the server with every packet. If you sent a heartbeat packet, and you could send millions of them and pump out data from the server until you had complete email messages, secret encryption keys, and all sorts of stuff. And this turned into such a scandal that it changed the world's perception of Linux security forever. Before that, people said Linux was more secure than Windows. But at this point, if you had just paid for your software, if you had Windows Server, it was not having this problem. Apple's did not have this problem. It was Linux servers, and everybody had to go to their boss and say, for the last 2 years, our secure server has been leaking data everywhere. We have no logs, and there is no way to tell how many people stole it or if they stole it. And by the way, I'd like a raise. You know, this is, and everyone said, you know, why did you use this garbage? They say, well, it's Linux. They say, who wrote it? Some random drunk in Finland wrote it, and nobody ever checked it. And they say, why are we using this stuff? Why don't we pay Microsoft and get a professional product? And people sort of shut up about Linux being more secure than Windows. There were like 3 or 4 disasters like this where the open source model that they bragged about so much revealed itself to have the same thing that all the stodgy, boring, Dilbert-like managers have always said, I don't know, if you're not paying people for it, how do you know they're doing good work? That's kind of an issue. Anyway, so All right, there's this video. I may play it later, but I think I'm not, because I think I'm rather do the lock picking today. Anyway, so your IP addresses are an old-fashioned IP version 4, which is still the most commonly used protocol, although it's gradually being replaced by IP version 6. You have these numbers, which are actually a pretty terrible idea. These numbers are in base 10. The IP address is really a 32-bit binary number. But for some ungodly reason, to try to make it easier for humans to remember, they turned it into 4 base 10 numbers that go from 0 to 255. So you have to get good at turning base 10 into base 2 to understand this. And this gives every generation of engineers a headache, and now it's your turn. So anyway, in the early days, there was only one type of address. The first number determined what network you were on, and the other 3 numbers determined which specific host at that network you're on. Everything with an IP address is called a host, because in the early days, computers were expensive, and every one of them would have many clients. Now, even your webcam and your printer and your laptop are still called hosts, because they have IP addresses. So your original plan was the first number tells me which company you're at, and the other 3 numbers just tell me which device at that company. So the entire thing could never serve more than 200 companies, 250 companies. They thought that was fine because the original internet had a total of 4 servers on it, and nobody thought it would go much further because computers were super expensive, and nobody could believe how rapidly they would decrease in price. So after they ran out of room on the original internet, they then split it, altering IP version 4, requiring an update of all the devices on the network to handle this classful system where we switched to classes A, B, and C, and there's also classes D and E, but they're almost never used. So this is the system that was used from, I think, 1980 until 1993. And even though it was later revised again, you have to understand it to understand what came later. So class A is the first half of the internet from 1 to 127, although really 126, because 127 is reserved for loopback addresses referring to the same machine. So there are a total of 127 possible networks, and each one of them can have 16 million devices because they have 3 whole bytes, 24 bits to vary, to address all their devices. And these have been gone for decades. The only companies that have Class A addresses are like IBM and MIT, and the few people that were in on this from the very beginning, AT&T, things like that. Then Class B was the next wave, where you have 2 bytes to specify your network address. City College has one of these, 147, 144. 2 bytes to determine your network. There are 16,000 such networks, and they can only have 65,000 devices on their local network because there are 16 bits to specify the network. And the cheapest and most common is Class C, where you have 3 bytes to determine what network you're on, and only 1 byte to vary, so you can only have 250 devices with IP addresses. Now this sounds like not enough, but in fact, it doesn't matter because nobody put public devices on everywhere. All you do is you put public devices on your public servers. And this college has 10,000 computers, but we only have 30 public-facing web servers, so we really only need 30 public addresses. And I've been trying to sell our Class B for the last couple of years. There are legal and political obstacles, but it's worth $1 million on the open market, 65,000 public addresses, and we only need 30, so we could sell it for money, but it hasn't happened yet. Yeah?
The bytes,
Yeah.
1, 2, 3, isn't that associated with the mass? You have one number, and then a bunch of random, that'd be the Class A.
Yeah, there's a subnet mask coming up here. Let me go ahead here.
Those are associated with them. It's kind of works with them.
Yeah, there's just another way of expressing the same information. So in Class A, this is the simplest one. You'll have 4 numbers. The first one determines the network, and the next 3 determine the node. So Class B, you'd have 2 numbers, like City College has 147, 144, 00 to 147, 144, 255, 255. 2 numbers determine the network. That's called a Class B, and we have 2 numbers to vary, the index devices. And here's Class C. You have 3 numbers to determine the network and 1 number to determine the node on the network. So, and here's the subnets I think you were talking about. You can express this with a thing called the subnet mask. Where this is a binary number where you have a 1 for the network portion and a 0 for the host portion. 8 ones gives you 255. So Class A has a subnet mask of 255.000 and 255.255.00 for Class B, and 255.255.255.0 for Class C. All right. So you cannot have all 0s or all 1s in either part of the network or the host. And You have to have a gateway. They'll have a couple examples of these to look at. Now, some people put manual addresses on every device. Unfortunately, City College does it this way. We don't use DHCP very much, which leads to endless problems. Because if two people put the same IP address on two different computers, which can happen, then you have the same kind of conflict as if two people tried to have the same telephone number. What happens is the first one to boot up in the morning will connect, and the next one will get an error message. Then tomorrow this guy will show up first, and you won't be able to figure out what the problem is very easily. It's very annoying. Anyway, so let's try a couple of these. I think you use the iClickers for these, and there's an extra credit project where you practice subnetting. If you put manual addresses on devices, which is typical for things like servers, you have to plan how to put those addresses. So let me explain these things. Here's a few just ordinary questions to answer. All right. So in this one here, I've got an IP address and a subnet mask. What's the network portion of that IP address? I'll quit at 25. Looks like the answers are coming in.
Everyone we get right, we get one extra credit point?
No, if you get the most right, you get 3 points. And only the people that get the most right.
On the average, so if I get like a B or C.
You won't get any points. You have to be the one at the top.
Oh, that person has to be on the top.
Yeah.
So somebody in here might get extra credit.
Yeah, or people with similar points. If this your class, maybe 4 or 5 people will get the points.
Oh, okay.
All right, anyway, the main purpose of these things is just to stop people from falling asleep.
Pay attention, I see.
Yeah. Anyway, so that's 10. This is a 255.0.0.0, so this is the network portion is the 10. The rest of it is the host. So let's try another one of them.
Like this.
All right, how about this one? What's the network portion of that address?
Professor,
Uh-huh.
do you code?
Yeah, but I'm not very professional about it.
Okay.
I'm not as good as you can find over in the other department. Yeah,
You're not considered, you don't consider yourself as a coder, right?
No, I've done plenty of it, but I'm not a professional level coder.
Okay.
I write little things, but
So coders are called coders. What are network people called?
network engineers typically. Yeah. All right, so 172.31. That's the first 2 bytes of that one. All right. And how about this one? What's the network portion of that address? All right, 25 will do. So it's the first 3 bytes, of course, so that's C. A popular answer. All right. Now I got another group of these to look at. I think that's all we're going to do today. A little bit more after that, but then the lock picking. All right, so here's a network. This is the kind of network that Microsoft recommended up until 2002, and you can still do it this way. And this is what most people have at a home network. So you've got computers, and your computer has 3 numbers. Every node in an IP network has to have 3 numbers. An IP address refers to this specific device. Then there's the subnet mask that tells me how big the network is, which class it is. And then there's the default gateway, because there are 2 possibilities. I might be printing to like a shared printer over here, in which case I just want to send traffic from one device to another on my local network. Or I might be going to the internet, in which case I have to lift off this network and get out of here. So that's what this default gateway is, the special device that has the ability to reach the internet. So if I want to talk to Google, I have to send my packets to this number, 192.168.1.1, which is the router, and the router has 2 interfaces, one local and one to the internet. And it also understands that it's a router and it's running routing software, which will check the addresses as they come in and decide which addresses to send to the internet and which addresses do not need to be sent to the internet because they're internal traffic. So that's the 3 numbers you have to have on every device. The router has a different default gateway which points out that interface. So it knows internet traffic goes out there to go up to the ISP. So you could use a computer as the gateway out of your network, but very few people do it this way because the computer is too valuable to waste in such a role. It's better to buy a special Linksys router for $40 or something and not tie up a computer being a gateway. Anyway, so this is a good network. You have a IP address here. Now here's some rules for networking. Every device has to be on the same subnet. So the subnet, this network is 192.168.1.0 because it's a class C network, 255.255.255.0. So the first 3 bytes determine the network. And if you put a 0 at the end, that is not a number you can put on a device. That is the name of the route that goes in the routing table. That refers to all the computers on this network. So everything on this network has to be there. So everything has to start 192.168.1. If anything starts with something other than 192.168.1, it won't be able to send or receive any traffic onto this network. And this is what happened to several students that have been asking me questions during the break. I've set up my 2 virtual machines, and my Linux machine cannot see the Windows machine. They're probably not on the same network. You have to check your network settings. They have to both be on a NAT network or both be on a bridge network, or they won't be able to see each other. So the first thing is the subnet mask has to be the same everywhere. They all have to be on the same network. Then they have to have different addresses. This is 1, 101, 102, 103. It can be any numbers, but you can't use the same number twice, or there'll be a conflict. And the last thing is these default gateways all have to point to the router. If that's wrong, then one of these machines will not be able to reach the internet. So I got a few examples here where there's a problem. They have to tell me which machine has the problem. So it would be A, B, C, or D. Okay. So here, these are example problems. If 2 of them have the same address, then one of them is not going to be able to get anywhere. One of them will pop up an error message and say, I can't connect. So here we try to use 101 on 2 different devices. Here's another problem. If you put a 192.168.2 down here, this machine will not be able to send or receive any packets because it's on the wrong network, and all the other devices are expecting 192.168.1. Here's the wrong subnet mask. If you put 255.0.0 on this one, it will not be able to send or receive any packets. Mathematically, it makes sense to me that it would be able to send local traffic, but not internet traffic. But if you try it with real machines, I tried it with Windows XP, it can't send or receive anything if you put on the wrong subnet mask. All right, and here's another one, the wrong default gateway. This one has 1101, so it can do local things like access shared folders and printers, but if it tries to go to the internet, it's going to send its internet traffic to machine B, which is not a router, which will just throw it away, and that one person will not be able to read their email. So, what's wrong with this one? I'll start the iClicker listening. Which one of those machines is wrong? So choose.
Don't tell nobody.
So choose A, B, C, or D.
You're not supposed to say anything.
Yeah. Well, but that's why it says all extra credit. These iClickers are not very scientific. You know, people could be looking at the guy next to them, or various things could happen. So I don't deliver quizzes this way. There's the online quiz system, which is hopefully a little more professional than this. Anyway, all right. I think I'll quit at 40. Looks like the answers are pretty much in. All right, so the answer is D, and a lot of people got it. The problem with D is D has got 192.168.1.1 here, which conflicts with that. So this is wrong. Now, you might argue that this is wrong, but it's not, because you need to refer to the gateway, and the gateway is down here. So the way to fix it by changing one machine is to change this number to like 103 or something, and then the network will be fixed. Yeah?
In this system here, isn't it all those items self-assigned?
And that's the way it's most often done is with TCP, but for things like servers, you can assign a computer to make these mistakes. But yes, that's why automatic assignment is very popular, because otherwise you have to understand this and do it yourself, and people make mistakes. Yeah?
But then you use TCP and like say Windows 2012 R2 or R1,
you can use it.
This subnetting it yourself and then reassign it on the IP address.
Yeah, so you can use DHCP for anything, but you typically don't use it for servers, because servers have to be found and you have to publish their addresses, so you don't want the address changing. So typically inside a server room is where you really have this problem. And you wouldn't set up the clients this way because it would just be a headache. Especially now that everybody has mobile devices and they're bringing in extra devices and connecting them, you just use automatic addressing is the normal way you solve this problem. There was another question? Maybe not. Well, let's try another one of these. All right, what's wrong with this? Oh, okay, that's a problem.
We need more than 30 seconds, that's for sure.
Well, I'm watching to see how long it takes. I wonder if I can move this up. No, apparently not. Move it up by making it a little smaller, maybe that'll be better.
Okay.
All right.
Can you move the clock up too?
All right.
Thank you.
Sure. All right. Guess I'll quit at 45. Looks like the answers are mostly in. All right. And again, that's D. A popular answer. D has a subnet mask that's not getting anywhere. 255, 255, 255, 255. That's really messed up. You're not getting anywhere with a mask like that. It's all network and no host. All right. How about this one? All right. I'll quit at 40. Looks like most people are done. All right, and that's B. B has got an address outside the subnet. He's got 192.168.0 instead of 192.168.8, so B is not going to be able to send or receive any packets. I should mention, there's a homework project where you do this, and I sent it out in the previous section of this class, and this guy sent it back, and I said, well, I'm wrong, she only got 9 points. And he said, no, check it again, I got it right. So I said, no, I checked it, it's still wrong. He said, look, it's right. I know I'm right. Why do you say I'm wrong? I said, dude, it's wrong. He said, look, I'm a professional engineer, I'm Cisco certified, I do this all day long, you're just a stupid college teacher, you don't know anything. What is your problem? I'm right. And I said, well, that could all be true, but this is still wrong. And I just mention this because there is a psychological problem with this business and all nerds and tech people in general, that they get an attitude that I'm smarter than those stupid users, and I'm pretty much smarter than my boss, and I'm smarter than everybody, and why isn't everybody bowing before me like they should be, because I know TCP, and who are you? You're just a worthless worm under my feet. And you've got to watch this. This will happen to you because you know something that is complicated and confusing, and people are always coming to you for help. Like, for years, every time I see my family, all I could do is fix their computers all day. Because every Christmas and every Thanksgiving, you spend all day fixing all their stupid computers. But it has an effect on you. So watch out for it. It is the occupational hazard of this business that you think you're smarter than other people. This will really hurt you in success. You can't be treating people like this, especially your boss, for example. You probably know more about technical stuff than your boss, and that's not because your boss is stupid. That's why your boss hired you. So you would do the technical stuff, and the boss could do something else. So you sneering at your boss for not knowing technical stuff is just proving that you don't even understand what's going on here and preventing him from promoting you. So anyway, just be aware of that. I just mentioned it in passing. This is going to be a problem you'll have to cope with. Yeah?
Can you please say why the C is cannot be networking?
Cannot be which? Yeah, what's wrong with B? The problem is, it's got an address of 192.168.0, and all the other devices, including the gateway, are on 192.168.8. And the subnet mask is 255, 255, 255, so all three are used for networking. So this is on a different network. It won't be able to send or receive anything onto this network. It would have to go through a router to get lifted from this network and put on that network.
So
Yeah.
what about the default gateway?
The default gateway is okay, but it can't reach the gateway because it's on the wrong network. This is the right number, but it has no way to get there.
I mean, relative like P relative to A, it's different. Like you see like 147, 144, 51.
Oh yeah, that's because the default gateway actually is connected to two networks.
But
So this is the address of the other network.
yeah,
So if it wants to reach the internet, it'll send it out its other adapter. The rest of them will only have one NIC.
yeah.
Okay, good. These are good questions. Yeah.
Could you make it a little bit bigger?
Well, I can make it bigger only by making it lower.
No.
So that's been the
What
problem.
else you can do, you can hide that top.
Yeah.
I don't think I can.
No, you can, right click,
There's no way to hide it.
yeah, hide, see, hide toolbar.
Yeah? Oh, thank you. Good. I didn't know that. Good. All right. Good. Yeah.
See, that thing that you're just talking about?
Yeah. Good. Good. So we need something. Good. Yeah. What's up?
Is there software that actually can help you, I guess, do a diagnostic?
Software that does what?
There's a diagnostic, and you're comparing all this after you've laid it out?
There probably are like websites and stuff that will compare it, yeah. But you need to be able to do it in your head in this business. Yeah. All right, but yeah, that's fine. That's the example. Here I'm a stupid teacher who don't know stuff. Be aware of that. You guys all know stuff I don't know. I hope nobody's under any illusions about that. And we'll carry on. All right, so what's wrong with this one? Oh, okay. That's a problem, all right. I'll wait till 40.
It's a good way to keep people's attention, that's for sure.
Well, I hope so. Yeah. All right, so this should be B. Yep, there it is, because B has a bad gateway. 172.16.1.101. In fact, B has itself as the gateway, so it's not going to be able to send packets anywhere to get to the internet. All right, let's have one more of these. What's wrong with this one? Oh, that's a problem.
I don't see it.
It's hard to see. That's why this system is not popular, because it's very easy to have little problems that are hard to see. This is like the one that guy got so mad about. A little problem that you can easily not see.
I had a computer programming class like that, and I told the teacher, and
Yeah.
he showed me the problem, and I told him, I said, sneaky, sneaky.
They get that. Anyway, I'll quit at 55 here. Yeah, it's very easy, especially in computer programming. There's something like a quote or a comma missing, and everything is shot.
Yep.
Oh, yeah.
Yeah,
I said,
and you have to get used to that. That's a real hard skill, like playing chess, learning how to spot the little bug. And so here's the problem. The problem is A. That's an 11 up there and not a 1. So this is 10.1.1.11, so none of these guys are getting on the internet. They all think the gateway is at 10.1.1.1. And it's very often the case that the numbers are similar visually. And it's hard to spot, especially if you're in a hurry and you're just seeing what you expect to see. Anyway, I got a couple more things here. There's the answers. Yeah,
so
go ahead.
You said that the problem with the A is because the gateway address is different?
Yes, because this is 10.1.1.11, so there are two ways to fix this network. One is to change this one number, and the other is to change all three of these numbers. If you change all these to 11, it would be okay. But typically, you use 1 or 254 as the gateway just for convenience, the start or the end of the run. But so if you want to fix it by only changing 1, it has to be A. Good. So, like I mentioned, there is IP version 6. We used to have a class in here and a certification, but it wasn't filling up anymore. I think that ship has sailed. But anyway, IP version 6 is coming, and it's going to be used in addition to IP version 4 for probably the next 2 decades, and eventually IP version 4 will fade away. And in IP version 6, the main difference is the addresses are much longer. This is an IP version 6 address, 2001 CO8 3700 FFF19. It's 8 fields. Each field has 4 hexadecimal digits for a total of 128 bits, which is 4 times longer than an IP version 4 address. So there are 4 billion IP version 4 addresses, and there are 256 billion IP version 6 addresses. So it is extremely huge, and we shouldn't ever need to use anything else for the next couple of centuries anyway. And that's the plan. But the addresses are going to get really long and ugly. Yeah?
But can our infrastructure handle it?
Yeah. Now almost everything is upgraded, and that was pushed by the US government. They didn't pass a law, but the US government passed a rule that all military equipment had to be IPv6 ready by, I think, 2010 or so, and all civilian equipment in the government had to be IPv6 ready by around 2008 or 2012. So the result was everybody upgraded their stuff so they could sell to the government. And all Microsoft Windows systems and Apple and everything have all been supporting it for years. And most people have it. A lot of people have it. If you have Comcast, you're actually using IP version 6 at home now, and have been for about a year. Most people don't know it, but if you do ipconfig, you'll find you really have one of these IP version 6 addresses on your home machine now. Yeah?
Yeah, you said it's gonna start? They just said it's gonna start for a long time. When is this gonna start?
It has been out there since 1993, but it only started being used to any significant extent about 4 years ago. And now almost all your home routers and all your ISPs and everything are now supporting it. Google switched very early, and France switched very early. So that was the main traffic, was all the YouTube traffic in France was going over IP version 6 about 4 years ago. And now it's up to like 20% of all traffic going over IP version 6, mostly to Google servers and Comcast customers, because Comcast upgraded to it. A lot of other ISPs aren't using it yet, and a lot of mobile devices don't have it. So, you know, it's everybody has to serve their stuff over both IPv4 and IPv6. And that's what I do, by the way, because I use Cloudflare, which is a free proxy service. So if you do dig of any samsclass.info, I should have, they finally blocked the any. All right, fine, be that way. I'll do A. If I do A, it'll give me my A address. I have 2 IP version 4 addresses. And if I do quad A, I'll get my IPv6 addresses. And there's 2 of them. So I have 4 addresses that can be used to get to my website. These 2 IPv6 addresses starting with 2400, and these 2 Class A addresses, and that's what you should do. You should have both 4 and 6 addresses for your servers so that people can come in over either protocol. If you don't, then people will have to go through a translator on the way, which tends to slow down and create problems, and some people might not be able to connect at all because they have only one protocol or the other. So anyway, and so you ought to learn binary. You might have noticed the hexadecimal there. There's hexadecimal in Wireshark and in machine code. You get used to it. If you don't know your binary, you'll just be constantly humiliated. In this business, it's like being a musician and not being able to read music. You know, you can get along for a while, but you'll keep ramming your head against a clue that you should learn binary. So I put in a project where you can just practice this, and I think I'll start it next time, but I plan to do a little bit of this in every class so you get used to it. Someplace down here, here's binary games. You can get up to 40 points by playing these little games. I modeled this after the Khan Academy. The Khan Academy is the free online math training course that is so much like a game that the children in 4th grade are doing integral calculus now. If you do math in little chunks and then practice, it's not hard. So I'll be going through that in future classes. But for this one, let me see if there's anything else important up here. Yeah, we'll talk about this binary stuff a little later. Right now I'm gonna let me just mention the coding systems that matter most to us. Binary is what the computer uses at every level. Everything is really just a long string of zeros and ones. That's all the processor ever cares about. So 8 bits per byte, you have 8 ones and zeros, and that's 1 byte, which can encode 1 character. Hexadecimal is where you use 0 through 9 and A through F, and 1 character has 4 bits. So 2 characters describe a byte. You have things like FF for 255. Base 64, you take 6 bits for every character, which is kind of screwy. This takes 4 characters to encode 3 bytes, and I think I got a picture of it. Yeah, so you use 64 characters, capital letters, lowercase letters, digits, that should say 0 through 9, by the way, plus and minus. And that's a total of 64 characters. So each character encodes 6 bits. And here's an example. If you have the string oracle, each capital letter turns into 8 bits of ASCII. So this is 0, 1, 0, 0, 1, 1, 1, 1 for an O, and a different pattern for each letter. And if you group it into 6 bits at a time, you take the first 6 bits and put it here, then the first 2 of that one and the first 4 of this one go here, and so it turns into more characters, 6 bits at a time, and each of those turns into a base 64. So Oracle in base 64 is T1JBQ0XF. And this is how a lot of people put encrypted data and data that's being scrambled to make it harder to read, and binary data is sent this way in email. And you'll see quite a bit as we go ahead. You'll see hexadecimal and base 64 used frequently, and you'll be practicing them with these binary games to get good at them. You have to be ready to spot these things. Hexadecimal is, base 64 is easy to spot because you see capital and lowercase letters and numbers and a couple of punctuation marks. Whereas hex, you only see the letters A through F. You'll never see a G or an H or anything. So that's one way to spot them. And you'll see them in the projects. You have to get used to these crazy things. All right, so let me turn off the recording, and I'll see who won the iClickers, and then we'll do the lock picking, which I brought the equipment. I couldn't find the equipment last week, but now I've got it. So let me stop this, and this is 123, chapter 2B. All right.